first question, which was, hey, when will these recordings be shared? I assume I recognize some names from yesterday, so I think a few of you took the webinar yesterday. These recordings will be available definitely by next week. I'm going to email all of you with links to the recordings, and they could post it to our training site. Our marketing team just gives it a little polish. They kind of put some bookends in front of them, behind them, so they look nice. So expect to see both the slides as well as the recordings for these sessions, and a lot of these will help you for certification. So clearly, you probably want to have a look at these as you're going through that as well. All right. So I think another question is coming in. Oh yeah, it's just a thank you. Yeah, you're very welcome. No problem. So as most of you probably already know or have been asking, this webinar actually prepares you for that level 2 certification. Yesterday, for those of you who attended, that prepares you for level 1. Today we're going to see this level 2 Sumo Power User. So this is the webinar that you're attending today. It's using Sumo Logic webinar. And you notice, let me make this a little bit bigger for you guys. You notice that there are some hands-on labs. As a matter of fact, what I'm going to do is I'm going to be walking you through some of the exercises there which highlight really well some of the concepts that we're covering, so that you get a good sense of what these labs look like. But if you're able to go through this webinar and go through these labs, that prepares you really well for that certification. This lab actually has credentials and all that good stuff for you to be able to log on to the exact same training environment that I'm using here for this webinar. So you will actually see the exact same results and all that good stuff. All right. So with that said, what we're going to cover today is how to become a Sumo Power User. I'm not going to go through the demo that I did yesterday for that point number 1. I'm just going to talk to it. For those of you who haven't seen it, you can definitely watch the recording. But then we're going to start talking about a bit more of the advanced analytics, the tool set that you have for advanced analytics. We're going to talk about monitoring trends and critical events, so dashboards and alerts. In specific, we're going to talk about creating meaningful alerts, not just alerts, but alerts that actually get rid of all that false positives. With a little bit of time, we'll talk a little bit about some use cases that are out there, how to use our community, and that's what else is available to you guys. So, like I mentioned, we're going to be using that training environment. Here are the credentials. Again, this is all part of the labs. Is also listed in there, and this prepares you for that level 2 certification piece. For those of you who are on the newish or newer side, yesterday I showed you a demo, and I'd encourage you to go and just watch the video. But essentially, we were seeing how you can use both logs and metrics to analyze your environment. So you get notified of some critical event, whether it is an alert that you receive through email, or perhaps a Slack or a HIP chat message. Or you have a dashboard in your operations center. You can view that something's going on. You dive into the metrics to start identifying the what's happening in my environment, right? So what we're trying to do here is avoid you having to go to many applications to look at your metrics and then switch your chair or look into some other monitor for logs. We're trying to combine both metrics and logs for you, because metrics give you the what, but logs give you the why. Why is something going on in your environment? So I'd highly recommend that you check out that demo if you haven't seen it. But from a high-level overview, Sumo Logic's broken into 3 main areas in terms of data flow. You bring your data into Sumo, so you send your data to us via collectors and sources. And then once the data is in Sumo, we search and analyze that data and eventually visualize it through dashboards or alert you of critical events. We're not going to talk too much about number 1, but I do want to cover 2 points similar to yesterday for those of you who saw it, where we can collect just about any data, whether it's structured data or unstructured data. You could even send us a book. We could grab that book and we can index it, right? Once you have that book in Sumo, you can start giving it some structure. But the idea behind this slide here is to show you that we can collect from just about anything. The stuff on the top area of this diagram shows you what we call cloud-to-cloud integration, which is sending data from, say, your S3 bucket straight into Sumo. So you can send your CloudWatch data, your CloudFront, your CloudTrail data straight to Sumo. We also have integrations to Akamai for example, your CDF or WFAF services. And via API, you can do SaaS or PaaS platforms such as Google or Office 365 as well. Down at the bottom, we have separate from cloud-to-cloud integration, or opposite to cloud-to-cloud integration, we have integration with systems that you host in-house. So you can actually put a collector in each of your servers, in each of your host servers, and send your data over to us. Or if you don't have internet access on those machines, you can use this kind of solution here, where you have a centralized collector, and you use SSH or WMI to send that data over to that collector and onto Sumo Logic. Or similarly, you can send your data from your firewall devices, from your routers, from your firewall straight to syslog over to that collector and onto Sumo Logic. So this is the idea of getting that data into Sumo. We're not going to spend a lot of time in there. We're going to focus more on what do you do with that data once you have it in Sumo. Having said that, the last thing I want to say is every single message, every one of the log messages that comes into Sumo gets tagged or gets stamped with these 5 metadata tags. Which collector it came from, which source host it came from, the source name. The source name includes the name and the path of the log file, because a lot of us we're very familiar with that information as we have searched through logs in the past without any log analytics tool. So we give you that capability as well. But more often than not, you're going to be using source categories, something that you set up initially that is going to make it a lot easier for you to search. And you'll see some good examples as we go through this. Okay, so a little bit of review, search and parsing. The idea behind this is, how do I filter my data and how do I provide structure? And you guys have seen, we use metadata, we use keywords to search for your data. And I'm going to use the same examples that we were using yesterday. So let me just open a new search in here. And for metadata, if you notice, if I put an underscore, here's all those different tags that I was talking about. If I choose, say, source category, it gives me a list of all my different source category. And in this case, I'm going to be looking for my labs Apache access data, which is there. So I can search data by using the metadata. And I can also use wildcards in my metadata, as you guys probably remember from yesterday. A bit of, for those who are new, I'm just covering this kind of stuff. Oops, sorry about that. I didn't mean to do that. There we go, Apache. And we can also filter that data by using keywords. So I can use the word, say, Mozilla. And this is pulling those messages that have labs Apache access. Oh, Apache access. Lab Apache access data that have the word Mozilla in it. So you start filtering your data by that. And of course, I can do things like I could have a whole bunch of ands, I can have ors, I can have nots, and all that good stuff, right? I could have done and not Mozilla if that's what I wanted to as well. Okay, this is fairly straightforward. We also have a tool called Livetail, and as the name suggests, Livetail allows you to, let me just cheat here, and I'm just going to go grab what's in here, copy it, and paste it. But Livetail allows me to look at my data in real time. So I can go and look and tail my logs. This is great if I'm a developer, because I now don't have, well, for one, I have access to the logs, and two, I don't have to jump into different servers. All the servers that have Apache access data are sending information over to me, which makes it a lot easier for me. And I can highlight terms. For example, I can highlight 404, so I can highlight the term Mozilla itself if I wanted to in here, right? I can scroll up, scroll down, pause. I can run multiple of these. If I can run another one in here and tail some other logs if I want to as well. Now, a couple of things to remember. This tail works without Sumo Logic hasn't indexed the data at this point. So I cannot do counts and sorting and all that good stuff that you can do when you're just searching your logs. And the reason for that is, again, this is just straight up grab the data from your servers and send it back to you guys so that you can start using this data. So if you actually want to start, once you get a good sense of what's happening with your data, then you would switch over to your searches so that you can start analyzing that data additionally. All right, so going back to this, I've shown you that you want to filter your data using metadata. You want to use keywords to narrow down the data that you bring in. You have a tool called Livetail that also helps you with that. But the key here is once you start refining your data. You want to start parsing your data. You want to start providing structure so that you can do something with your data. And I'm going to show you first how to do some query parsing, meaning how to parse within the query itself. So in this case, I have my data here. I have my Apache Access logs, and I'm going to show you the simplest way of parsing, which is grab a message, any message. It doesn't have to be this top one. As a matter of fact, I'm going to show you. I can grab any message that is down here. I'm just trying to find anything meaningful, but in short, what you want to do is you highlight that message of whatever you want to parse, and then you say parse that selected text, and you end up using this particular message as a sample for how you want to parse all the other messages. And the reason I can get away with this is because all messages for Apache Access look the same. So I know that the URL is always going to be between my GET and my HTTP. And I know that right after that, I'm going to have status code. And shortly after that, I'm going to have size. And shortly after that, I'm going to have the referrer itself. And shortly after that, I am going to have the user agent. So I can do exactly that. I can say size and referrer and user agent. Right? So what I'm showing you here is this nice little UI that lets you build this parsing statement. Of course, I could have typed it myself, but just a little easier if I get a little bit of help. So if I run that query now, you'll notice that my message has been parsed. I'm sorry, my message is still handled, but the fields that I had parsed are shown here as well. There's user agent, there's URL, there is status code, there's size, there's referrer. So now I could do things like count by referrer, for example, and run that query, and I can see what are my counts by referrer. I can sort them if I want to, and I can see what are my top referrers to my within my traffic in my information. Okay, but I won't get into the count and all that good stuff just yet. Let me also show you, I think yesterday I walked you guys, for those of you who were on, I showed you some examples of other parsing operators that we have out here. So I'm going to cheat here, and I'm going to go straight into our help, which is our documentation, help.sumologic.com. And in there is a search cheat sheet. And this cheat sheet has all the operators that are out there. So not only does it have all the operators, which are way too many for me to go through, but the good thing is that they're broken by functionality. So in this case, here are all the operators that have to do anything with parsing. I showed you the parse anchor just now, right? Parse regex, that's a cool one. That is, if my data is going to have variance, meaning that the patterns are not always the same, then I probably want to use regex to be able to do that. Let me just grab this example here. If I grab this, and for those of you who are new to regex, what this says is, look for this pattern that says 1, 2, 3 digits followed by a period, 1, 2, 3 digits followed by a period, 1, 2, 3 digits, period, 1, 2, 3 digits. That sounds like an IP address, right? So find that pattern and store it in a field called IP address. That's what this parsing statement is saying. Let's go add it to our query. I'm going to go here, add it to my query, run that, and what you'll see is that I've parsed the IP address as well. So a couple of things that I want to show you here. One is I can have multiple parse statements. Here's one, here's the second one. Second, those parse statements don't need to be the same. They could be completely different. In this case, I have an anchor parsing here, and I have a regex parsing down here at the bottom. So a couple of other options that I have from a parsing options are if my data is key value, something like name equals Mario, company equals Sumo Logic, I can use the key value operator. CSV files, JSON formatted files. A lot of these have an automatic operation. So let's see. I think I have some data here called, let's see, source category equals training. I think this data here, let's find out. I think this is in JSON. Let's find out here in a second. Yeah, all right. So look, this data is in JSON, by the way. We have the ability to view it as raw or to view it as JSON, but this is JSON data, right? What I'm going to do is I'm going to use that JSON operator. I'm going to go and say JSON And I could specify which fields I want to parse, for example, the name field, or I could just say JSON auto. And what it's going to do is it's going to go and parse, because we know what JSON looks like, we can traverse the JSON tree and we can go parse everything in there. So you notice that here is my message, and over here on the left-hand side, this is called the field browser. I've parsed out all the fields that I wanted to, that are in here, in this particular, or in all these messages in here. So let's say func name is somewhere here. Ideally, we would have func name in there. There it is. So now I can do something like count by func name. And function name is now a field. There's two values to it, charge and process card. And I can do a count by those if I wanted to as well. All right. So just wrapping up here in terms of what options I have from a parsing perspective. Sending something that is not necessarily comma delimited by something else, you can use a split operator, or you can use the XML operator as well. I'll show you a couple of other options that we have though. Let me go to parsing operators. And I want to show you, I should have said just parse operators. Here we go. There's a couple of options that I didn't show you guys yesterday, for those of you who joined yesterday. Here are a few more advanced options. There's a fields option and there's a no drop option. Let me start with a no drop, which is a pretty interesting one. As a matter of fact, what I'm going to do is I'm going to go to the labs and I'm going to use one of the labs to show you the example. I'm going to go here. By the way, look, the labs start with some very easy, I'm going to make this bigger. The labs start with some very easy queries that you guys can copy and paste and try them out in your own environment. This will give you a little bit of sense to try some of these things. But the one that I want to show you in particular is this no drop operator. Let me just grab it first, and then I'm going to walk you through it here. Let me copy this, go to our instance, and just put it in here. All right, here's my query. Let me show you first what the data looks like. So I'm going to comment out some of the ones in here and just run it. Okay, I'm looking at Labs Apache error, right? So in my Labs Apache error, let me make this a little bit bigger so you guys can see it easily. Okay, in my Labs Apache error, I have a couple of different types of messages. Look, I have this one here that says error, database connection error, and then some sort of a message in there, right? So this one looks very similar to this one, which looks very similar to this one. But here are some other types of messages. Look at this one. This one says error, and then I have some client IP address, and then some sort of a message in there. So the I would say the parsing that I would do for one type of error, let's say this one, would be very different than the parsing that I would do for, say, this kind of error here. So this one says mod log SQL. This one says client and an IP address. How would I parse these different ones if their patterns are variable as well? So let me walk you through this example. If I were to say, hey, listen, I just want to parse the client IP address. Let me get rid of this no drop for now. I just want to parse client star as client IP. So find this pattern that says client within brackets and take whatever is in here. And if you look at the messages, what that is this here that I'm highlighting. I'm trying to extract the IP address, right? All right. So if I run that, let me show you what happens. It runs it. It finds all the messages that have that pattern, and it extracts the IP address as I expected. That's great. That's pretty cool. But also the other thing that it did is it, by default, it dropped all other messages that do not have this pattern. If that's what you want, then that's golden. And about 80% of the time, that's what you want. But there might be 20 or 10% of the time where you might not want to drop those messages, because with the messages that actually got dropped, you want to do something with it. So that's where our option to no drop comes into play. So let me show you this. If I say parse such and such and such, no drop, what happens is the other messages that do not have that pattern, like look at this third one over here, that one doesn't have that pattern, but it doesn't get dropped. It stays within my results. But of course, I cannot extract an IP address because there is no IP address in there. So my no drop is a way of keeping messages that do not have a certain pattern, because maybe what I want to do is have some other parse statement that is going to parse additional information out of those messages. So look at this. Here's a case where this message has the client IP, so it parses those. The message is blank because it doesn't have that pattern in here. And in this case, it's the other way around. There's no IP address, but there is a message to it that got parsed out of that. Right? So think of a no drop in this case as an or statement, right? I'm saying find this pattern or find this other pattern down here. And then you can play with things like give me only those messages where client IP is blank. And in that case, you're just selecting the messages where you have messages or client IP is blank. Okay, pretty cool. Let me show you another option that is pretty cool. Parse field. I haven't used this one that much before to show you guys, so let me show you a little example in here. I'm going to cheat copy this whole thing, paste it into a new search, and show you this option. Let me choose the last 30 days because I don't think I have much of this data. So what I'm doing here, actually, before I show you the results, let me comment some of these out. What I'm showing you here is my GitHub data. I not only have GitHub data, but I'm only looking for those messages that have the word committer in it. And what I want to find out is who are my top committers? Who are the people that are committing most of the code into my GitHub repository, right? So here's a whole bunch of messages for the last 30 days. As a matter of fact, about 700,000 messages. That's a lot of messages with the word committer in it. What I want to do is I want to parse out the email from it. So I can run this query and say, okay, look for this pattern and parse the email out of that. It's pretty straightforward, right? This is called anchor parsing. Look for the word email, look for the colon after that, and then grab anything that is after and pull that out. Okay, but what if I want to do additional stuff? What if I wanted to pull the domain and the user out of this? So here's the user and here's the domain. Well, then I can refer to that email as a field, and I can say, I want to parse the field called email and grab anything on both sides of the @ sign, and that's going to be user, and that's going to be domain, right? I can then use those fields. So for example, I can say where domain equals, perhaps I only care, oops, perhaps I don't care for the Gmail accounts, or domain, yeah, domain equals Gmail, right? Because or perhaps I only want those, I should have said, by putting this value here. So that is just that's only going to bring me those domains that are in Gmail, or maybe you're looking for your own domain or whatnot, right? But it's now a field because it got parsed from another field. And just to complete what's in here, I'm just going to show you that then you can do perhaps a count by users, and then just choose the top users by count. And this would give me the top 5 users that have been committing stuff into our repository in the last 30 days. There you go. So another example of some of the parsing options available to you. All right, I'm going to show you one last parsing option, and it's called parse multi. And I'm going to do it again with an example from here. Parse multi, let me see if I have an example here. Yeah, let's do this one here. All right, let me grab this, take it in here, and see, I'm preparing you guys for the labs, for the exam already by going through some of these labs. All right. So let me show you this. Here's my snort data. Snort data is data intrusion data, right? Security engineers would use this data to identify potential bad traffic, some attacks, information leak, and all that good stuff, right? So what if I wanted to pull out some IP addresses from this? Well, if I go here and I say, okay, just give me parse out the IP address, like I'm asking here. We've seen this line before. It will parse out the IP address as I expected. If you notice, here it is, 11.69.144.215, just got extracted in here. But it so happens that snort data happens to have a second IP address, or a third one, or a fourth one, right? How do by default, parse regex, when it finds one IP address or one pattern, that's where it stops. Parse multi allows me to say, hey, you might find this pattern numerous times within one same message. I want you to extract each and every one of the values from it. Perhaps you have several users within a message. You have several emails within a message. Multi allows you to do exactly that. So if you notice in here, what it did is it extracted the first IP address, 418.70.89. It was, is right here. And the second IP address, oops, sorry, the second IP address, the 10.24.171.31, got extracted as well, and it just made a copy of the exact same message. If you notice, these two messages, 1 and 2, are exactly the same. I just extracted 2 different IP addresses from each. And now you can do your counts and all that good stuff from it as well. All right, so I'm giving you a few more advanced options in here. Query parsing has quite a few options to it. I talked about field extraction rules, and I cannot talk enough about it. This is definitely something you guys want to do. What's a field extraction rule? Well, as the name suggests, what it allows me to do is similar to parsing. It allows me to extract fields, right? To parse out fields, but it allows me to do it ahead of time, so that I don't have to be doing this querying this parsing every single time I run the query. So let's go back in here. Remember our Labs Apache access where I was parsing out URLs, status code, size, refer, user agent, all that good stuff. Let me show you a little trick. I'm going to run this same exact query without parsing anything. And what you will see is here's the messages, and in my left nav, I have those fields. There's source IP, there's status code, there's URL, there's user agent. These didn't happen magically. There is a field extraction rule in place that is doing exactly what I need to parse out those fields. Where does that get configured? It gets configured under Manage Data, Settings, and in here there's something called the field extraction rules. And there's one here built for me, fortunately. Let me just go and edit to show you how that field was put together. But basically, what I'm saying here is anytime I have data coming into Sumo Logic, and that's actually good to know, field extraction rules take effect at the time that the data is getting ingested. So while the data is getting ingested, it checks for this source category. And if it matches, it parses out and indexes all these fields for you, right? So notice, it's parsing out source IP, method, status code, user agent, refer, those same fields that I was parsing out before. Parses them out, indexes them, and then they're ready for me to use as I need to in my environment. So that's where those fields come from. Just to show you how these are put together, let me click on a plus, and here's how you would go about putting one together. Let's say that I had Palo Alto network data. So I'm creating a field extraction rule for my Palo Alto network, and I would specify the scope, say source category equals, I'm just going to simplify it for now. And by the way, it doesn't just have to be source category. If you have something like collector equals ABC and source equals, so you could get as creative and complex as you want in here. It's just that if you guys recall, we try to use source category whenever possible because we, in theory, as we're sending the data, we've defined a source category that is strong and meaningful. For example, something like this, network, Palo Alto network, right? And then I could specify the expression in here, or we actually try to get you started. So for Palo Alto networks, we have a template. We know what the data looks like, so you can use this template. And all that it's saying is Palo Alto network sends us comma-separated stuff. We just take that and give it a name. And if you happen to have more fields to your Palo Alto network data, let's say that you had 2 more fields, here's one and here's the second one, then you can easily edit this and say here field 1 and field 2. And you just got yourself a field extraction rule for your specific Palo Alto network logs. Okay, So I cannot stress how important it is for you to start building your field extraction rules or work with your admins to build these field extraction rules, because these are going to give you structure. They're going to give you data structure, and now all of a sudden you can come into you or anybody else in your organization can come into your queries and right off the bat say, oh yeah, and status code equal 404. Notice I didn't have to parse it anymore. Status code is a field, it recognizes, and it's only giving me those messages that have a status code of 404 from Mozilla. And then I can do things like, let's say, I'm going to move into aggregation now. I can say now count by URL. So I can see what are the URLs that are giving me status codes of 404, and I can sort them and all that good stuff as you saw before. I can see the top URLs giving me that info, right? Okay, so very key field extraction rules. You want to get to those. This is where if we're delivering this face-to-face, we normally would have a little pause, get you guys to try labs 1 through 3. However, I've pointed you to where those labs are, and I highly encourage you guys to try them out. We've already gone through a couple of those here on these exercises. Let's talk a little bit about the simple analytics. So you now know how to parse the data. How to filter the data with metadata keywords, how to parse the data, and then you start doing some sort of filtering and aggregation. So from an aggregation perspective, the usual stuff, the counts, the sums, the averages, right? Again, the labs show you some easy examples. Let's see if there's anything here that I should pull out to try out. This is a good one. Yeah, well, why not? Let's just grab this one here, right? This one's using the if statement. Let's go back to our query. Actually, let's do an even simpler one, and then I'll try that one. What if you want to do instead average, because size is one of the fields, by URL or by IP address, right? So now you can see I'm only looking at those with status code 404, and now I can look at the average size of the message by a specific URL. I'm just making stuff up, but I'm just showing you, excuse me, the fact that you can take these fields that exist and start doing the aggregation with it. I'm going to open this one in here and show you one from the labs themselves. I'm shortening and coming straight to the chase, but in this case, what I'm doing here is I'm saying, okay, source category equals labs Apache access. I am parsing the status code itself, right? I don't even need this here because we now have a field extraction rule, but just to show you. And then I'm using the if statement saying if status code equals 200, then set the successes to 1, otherwise to 0. And if status code equals 404, then create a new field called client errors that has a whole bunch of 1s and 0s. So let's get rid of this one here for a second. If I run this query, what I end up with is my message, my status code, because it's what it's looking at, and then a whole bunch of 1s or 0s for successes or client errors. 1 if it's a 200, and 0 if it is a 404, and the opposite for client errors. So all you've done up to here is created new fields, if you will. And then I can do something like, all right, now sum up all those fields into a new field called success count, and do the same for client error count. And that gives me this result in here. So now I have a count of my successes and a count of my errors. So you notice how you can start doing some very straight up simple aggregation with this stuff. You can count your sums, your averages. You can use an if statement. Matches this I could have said, let's go back in here, if status code matches to star. Actually, I think I need to put this in quotes. Or if status code matches 4 star. Right? You get the point. I think you guys can all follow what it's doing. Oh, I put one too many. The results should be the same, right? Because I'm essentially there's only 200s and 404s. But you get the point. If I had 401s and 403s and 404s, I would catch them all through here. Okay, and then there's a few other examples for the filter operators. these are fairly straightforward. And then from a formatting perspective, not all the time do you care to have all the fields. So you can use the field operator, for example, in here. Let's say that, actually, let me go back in here. Let's look at these results. Here. If you notice, this results give me the client error, the status code, the message itself, and the success. So what I can do is I can say I actually only want client errors and successes to show. And to do that, I can say fields, and then I can specify which fields I want to show successes and client errors. And errors. And what that's going to do is it's only going to, oh, maybe I don't have that. Oh, successes. Sorry. It's only going to show me the fields that I am specifying. And then by default, it will always show you the message itself. The message is called the raw. So if I don't want to, let's say I want to show everything, but I can do minus as well. What are the messages that you don't want to show? So you can do minus raw, and it's only going to show you the fields that you care. If I didn't care for status code either, I would do status code because I'm doing minus raw and minus status code. So you get the point. Fields allows you to pick and choose which fields you're going to show. Why is this important? Because maybe at some point you might want to graph some of those values. You might want to do something with them, and you don't want to graph fields that have nothing to do with the graph that you're putting together. All right. Transpose, I showed you yesterday, the ability to turn a list into a table, and you'll have some examples to play with this again in your in the labs themselves that I'm showing in here. So there's a whole option around plotting stuff and trying it, formatting results. Okay, moving right along. So again, this is where we would pause, let people try some of the labs, some smooth, like the smooth operator, the diff operator, and try a couple of these things. But let me get to what I wanted to get to today, which is a little bit of the advanced analytics. So how can you identify outliers? How can you look for trends? How can you look for needles in a haystack? It sounds a little bit corny, but it's somewhat, the needle in the haystack is, how can I see things that I don't even know exist? How can I find those things, right? So let me walk you through some of the examples in here, and then I'll point you to some of the labs again that you guys can try. The first one I want to show you is this one called the outlier. As a matter of fact, let me go again and cheat, but this time instead of doing it from the labs, because I want you guys to try those out, I'm going to cheat from my own instance. I'm going to close some of these guys here, and in my own instance I have some training queries that I've already prepared. So I'm going to open some of these just to show you. I'm going to open this Lookup. Why not? I'm going to open the outlier one. I'm going to open this predict one. And while I'm at it, I'm going to open log reduce. Okay, good. Yeah, okay, yeah, that's good. Okay, so let's start with the outlier. What outlier allows me to do, actually, let me step you through the process, right? So let me get rid of this. What outlier is, what this query is doing is saying, listen, go find all messages with source category equals labs Apache access, and only find those that have a status code of 404. Pretty straightforward, right? We should all know how to do that now. Now, grab those messages and time slice them into 1-minute buckets. Since I have 60 minutes worth of data, this is giving me 60 buckets, right? And then give me a count of the status codes. So all I'm doing here is I'm giving it a better name. I'm giving it a name called server error count versus just calling it underscore count, right? So just count all the messages by time slice. And what this is going to do is it's going to give me a result that looks something like this. At this time, you had this many 404s. At this time, this many. At this time, this many. At this time, this many. Pretty straightforward, right? Just a list of times and number of 404s. I could sort them if I wanted to. I could plot them if I wanted to. And all it's doing is it's giving me a line of the number of 404s I had at a given time. Pretty straightforward and pretty cool. Well, what I'm going to do now is I'm going to use this outlier operator. And don't worry about all this stuff I'm highlighting here. As a matter of fact, let me cut it out. Command X, let me cut it out. What I'm doing is I'm saying, listen, I want to apply that outlier operator on this error count that you have here. What that does is it looks at the error count, as you would expect, but it also looks at the upper limit. It creates all these statistical numbers, upper, lower limit, the error, the indicator, the violation, the mean, the server. Why does it do that? Because it's going to allow me to plot a line similar to this one. So here is my count as before, right? There's that line like I showed you before. But then it also used messages in history. So it looked at 5 data points in the past and said, okay, what does a standard deviation look like for me now, considering the 5 previous points, or the 10 previous points, or the 50 previous points, whatever I want to choose. And then it plotted 2 standard deviations for me. But I could have chosen 3, 4, 5 standard deviations. How do I choose that? I choose it with these variables that I showed you here. So Windows says, how many data points do I want to go in the past to find out what the standard deviation should look like? Threshold means how many standard deviations. 2 standard deviations, 1. Notice, if I change this to 1, I am going to have a few data points that are outside of standard deviation because I chose a much smaller area for my standard deviations, right? It's a smaller standard deviation, so I have a lot more stuff outside. Consecutive says, should I point out every violation outside of the standard deviation, or should I wait for you to have 2 violations before I alert you, right? And if I change that, let's say consecutive equals 2, you'll notice that now my search has, here's a violation, but it didn't get flagged because there's only one of them, right? Here's one. Actually, let me wait for the data to settle so that I can show you this. But the point here is that it will only show me violations, or you will only get a little pink triangle in the case of where you've had 2 consecutive violations. So notice this one doesn't have one because it's the first one, but this one is the second one in here, right? And by the way, that is shown, if I go back to the data and I look at these 2 last, these 2 fields in here, error indicator versus error violation. So here is a case where I have an indicator, meaning you are outside of the standard deviation, but it's not a violation because it's not 2 consecutive ones. Let's look at this one here. You had a violation. I'm sorry, you had you were outside of the standard deviation. It's not a violation. Oh, here's the second one outside of the standard deviation. Now you are a violation, and you are also a violation because you've had more than 2 consecutive ones, right? So the violation field here corresponds to the pink triangles that I'm seeing out here as well. All right, and the last thing to show you here is direction. Direction says, do you want me to show you those things above or below, or only the ones above or only the ones below? And you can do that by getting rid of the signs. Just the ones above would be this, just the ones below would be this, and the ones above and below would look like that. So Outlier, an incredibly powerful operator, a very good tool. It is the way to identify outliers, anomalies, and start alert yourself of any critical events that are out there. And I'll show you later on how to do something like that. All right, the next one I wanted to show you was predict. And let me run this query so I can show you what it does. It's easier showing you graphically. But basically, it plots all the data points that you have so far. In this case, all I'm looking is at the number of requests for my Apache Access. So here's the requests themselves, and then it looks at the next 12 data points and broken into 5-minute buckets. So in this case, I chose an hour, right? 12 times 5 is 60. So for the next 60 minutes, how this is going to look. So this gives you a good sense of how many. Look, I can see from this line that my requests are trending down as the day goes on, right? So I probably get the big spike in the morning, and then I start trending down as I go. Okay, so a couple of other ones in here. Before I jump into log reduce, let me just show you this one only because it's pretty cool. This one is the lookup operator. And what lookup allows me to do is, if I have an IP address, plot that IP address, go grab the latitude and longitude of that IP address from a database that we maintain and we keep for you, and then plot those numbers in here. And let me show you the example. And while that is running, let me go find that GeoLookup operator in our help. GeoLookup, here we go. Let me show you that GeoLookup operator because there's a few more fields that are available to you. As a matter of fact, let me go grab them. Here we go. Not only can you get latitude and longitude, oops, you can also grab country code all the way to metric code here. Let me grab these, copy and paste into my query. So I need a comma and then all these. And I'm going to do the same here, comma and all these. So if you notice, I'm going to pull not just latitude and longitude, but country code, country name, region, and all that good stuff, right? And all I have to do is go to my map, and I can plot this data point in my map. So you probably saw some of this when I was showing you apps yesterday. This is how you do it. You actually create a, you look for the latitude and longitude, and then you just drop it into this little map in here. Let's say that we only care for the US. How would we go about and do that? Hopefully you guys are answering the question on your end. It's pretty straightforward. All I would have to do is put a where clause, right? Where country code equals, and then I put in quotes, US. And in that case, if all goes well, I would have a map that looks like that, just the US, because my data has only those where country code equals US. Easy peasy. All right. The next one I want to show you is this guy called log reduce. Let's go back into our snort data. Remember the network intrusion, identity network intrusion stuff that I was showing you before? Let's look at that data. Let's grab 15 minutes worth of snort data and run that query. Okay, so this query, for those of you who are not network security engineers, what this is showing me is it's giving me information of whether I've had a web attack, if I had some information leak, if someone's trying to gain some privilege and whatnot in my data. All right, if I'm the security engineer, one of the things that I could do is I could search for, is someone trying to do a privilege gain, right? So I could search for the words privilege, did I spell it right? Gain. And what would come back is anything that has that. Maybe just look for the word gain to see if I have it in there. And what would come back is anything, I had to spell it, anything that has the word gain in it, or privilege gain if I'm looking for the whole thing, right? Straightforward. So if I know what I'm looking for, easy peasy, because I can search for that kind of stuff. If I'm looking for the word leak, I can do that. I can search for the word leak. But every so often, you might get attacks that you don't know what they are. You've never seen them before. You have absolutely no idea how to search for them. So in that case, what you can do is you can say, all right, give me all my data. And if you notice, I've got about 1,500 messages in here. Let's grab more data. Let's make this interesting. Let's grab, I don't know, an hour's worth of data. So here's an hour's worth of data of this stuff. So there's 6,000 messages. What I'm going to do is I'm going to hit this log reduce button. This is the easy button. And it's going to go and compare every single message to each other and come back and say, hey, listen, there are, out of the 10,000 or 6,000 messages, about half of them were attempted information leak. And they all look very similar. Yes, that's a different IP address, perhaps a different port, but everything else looks very similar. So it kind of gets rid of all that noise for me. That's one of the errors that one of the attacks that I've already have under control, and I don't have to worry about it. There's this other called web application attack. There's about 1,000 of those. There's a sensitive data one. There's about 6,000. So for me, as a security engineer, it kind of classifies all these different attacks into signatures, and I can easily skim through them. If you notice, now I only have 2 pages to scroll through, right? So I can easily go through these pages and then also go to the last page where I might have attacks that I hadn't seen before. So look at this one. Oh, this one is a suspicious file name was detected. So I hadn't seen this attack before. Maybe this is something that I want to investigate and look into a little bit further, because this is something I hadn't seen or I wasn't seeing before. So how would you investigate further? Fortunately for you, there's a little link here to go look at the message itself. So I can click on it. It takes me to the message itself. It tells me which host this message is coming from, which source category is coming from. I can see the message. I can see the IP address that it's coming into and all that good stuff. Now, for most of this stuff, for most of the attacks, more often than not, you want to see them in context, right? Oh, it's great that I know that a suspicious file name was detected, but what was happening right before this file name was detected? So what we allow you to do is we allow you to look at the surrounding messages, allow you to look at the context of that stuff. So I can say, show me 1 minute before and 1 minute after this message. And now, yes, I enlarge the number of messages that I'm seeing, but these are the key messages that I care to see. So if you notice, excuse me, now I have 227 results. These are 2 minutes worth of data, right? A minute before and a minute after my message. And my message is in here. It's kind of square in the middle because you notice it's in page 5 of 10 because I have a minute's worth of data before and a minute worth of data after. And I can now scroll through this and find out what was going on. So log reduce is definitely a great way to keep an eye on the messages from a security perspective in this example that I showed you, to keep an eye on anything that is new that you haven't seen before and that you don't even know how to search for that. All right, so tied with that, I want to show you another one called log compare. So you're going to have to stretch your minds here a little bit so I can explain this to you. What log compare does or is doing right now is it ran a log reduce for 60 minutes just like we did before, but then it also ran a second log reduce for 60 minutes but 24 hours ago. So think of this. It ran a log reduce 24 hours ago and one for now. And it's comparing those signatures and it's saying, hey Mario, this is great. Look at this. This one that is in here, web application attack, it happened 1,400 times this last 60 minutes, but that is 5% less than what it was happening 24 hours ago. So it's comparing my attacks now to those 24 hours ago and telling me if they've increased or if they've reduced. So in this case, look at this one here. This one, attempt denial of service, so a DOS. I have 169 of those. That's 11% more than what was happening before. So I can see some trends going on. I can see trends of these attacks happening certainly a little more now than they were before. And it gets even more interesting because if I look at the last page of this stuff, I can see which ones are brand spanking new. So look at this one, potential bad traffic. Hey, this looks familiar. Potential bad traffic, Solaris IP scan attempt. I have one of those. This one's brand new. This means I did not see this attack 24 hours ago, but I'm seeing it now. So this is something that I should worry about. And this one down here, it's even better for me as a security engineer. This says, this attack is gone completely. It was there 24 hours ago, but I don't see it now at all. So that attack is completely gone. So log compare, log reduce, definitely your friends as you're trying to compare stuff to other time periods, as you're trying to reduce the number of data that you have in there. By the way, I just clicked the log compare button and it defaulted to 24 hours. You can choose a custom time period as well if you want to in here. So I just used the 24 hours to show you that. Okay, so with that said, there are a lot of very specific operators to help you with this with your data, whether you want to analyze a large amounts of data but don't know where to start. You have your log reduce, you have your log compares, or perhaps you're trying to identify outliers. In that case, you would use the outlier operator in there. Again, this is where we pause. Normally we send people to try some of these labs on their own. What we'll do here is we will pause for today. We're right on the hour, so this is kind of nice that I can keep these short. I'm going to pause here for a second. I think there's a couple of questions on the chat that I'll answer, and then we'll pick up from here tomorrow, and we'll pick up and start talking about dashboards and and dashboards and alerts. So let me just do this here for now. Let me stop the recording,